It's a good day, geography, great of learners. It is that time of the year again that we need to do revision, preparing for our preparatory exams, September, end of term exams. I just want to let you know that never get distracted. Just keep focusing and keep following. Metric Hub is there for you. We are here to do the right things at the right time, and you make sure that you never repeat because of the content coaching and time that you are going to spend on Metric Up. Not today, we are going to talk about climatology. We are going to look at climatology, microclimates. We're going to talk about valley climates. We talk about temperature, the influence of temperature in terms of microclimates. How does urban climate affect urban structures, affect uh city climates? We talk about the mid latitude cyclones. Just keep connected, don't go away, keep connected. And we're gonna talk about the effect of the cumulonimbus clouds. How does it affect the weather conditions associated with cumulonimbus clouds? I'm sure that you need to understand and you need to look at it without any chances of playing around. Tropical cyclones, we're gonna look at them and what are tropical cyclones? How are they named and the effect to do with the weather conditions associated with them, and also identifying the times and seasons that they have occurred based on based on synoptic weather maps. Weather maps can be used to give information about tropical cyclones, their direction of movement, the season in which they occurred, reasons why you can say that their pathway and all those things. So in today's segment, you shall find out that we are going to have a quite a loaded revision segment. We're going to talk about the anticyclonic conditions or anticyclonic air circulations that we're going to look at. The Kalahari, the South Indian, and the South Atlantic high pressure cells. How do they affect the weather of South Africa? These, I'm sure that you have seen that in our geography, we cannot do away with them. We talk about the subsidence of air. How does temperature inversion also occur? All those things, we're going to discuss them today. I'm sure that you're going to enjoy and you are going to have the best time of your moment. Just keep connected. As you can see, this is quite a very comprehensive session, and it's going to be so interactive and very interesting because of the content that we are going to go through. So please just be patient, keep connected, watch the videos to the end, and you shall see that your time will never be, your performance, your understanding will never be the same. So without wasting any time, we are looking at local climates, and there are words that are given that we're going to use to define and explain concepts that are below. We are given a valley climate here. So microclimates, I'm sure local climates, you need to understand this. We talk about city, we talk about valley. These are typical examples of microclimates. These are typical examples of microclimates because what happens is their climatic conditions and whatsoever that happens around them is quite a lot of it's quite a lot different from their surrounding uh places. So here is this is a river that we are given, where we are given an inversion layer, and we are given air that is sinking into the sea, I mean into the river, causing formation of frost pockets that are forming there. And then we're gonna have uh on the river banks or on the river sides, we have got frost sensitive crops, meaning to say crops that can grow without being affected by they are grown, they don't have too much problem with the frost. And then in the frost socket zone, we have got frost resistant. They must be quite resistant, these ones, in the frost zone, pocket zone. So what we are asked here is that the wind in the sketch is an is a dash type of wind. I was saying there are quite a lot of, I mean, we need to know types of winds. We need to know types of winds, types of winds. I'm sure you remember that we said that there is uh, conditions that causes air movement or wind moving from high pressure to low pressure, and also the issues of pressure being caused by variation of temperatures between the land and the sea, creating what we call land and sea breezes. I'm sure that we have talked about that in the various presentations. The land and sea breezes, air movements that are originating from the land going into the sea, and then the sea breezes also they are forming from the sea and then going to the land. These are air masses that are caused as a result of variation in temperatures between the land and the sea. So what we are given here is that the wind is blowing from the land into the sea. So what we call such a type of wind, we call that it is a katabatic wind. It's katabatic wind, uh, downslope wind moving from the land into the what, into the river. We call that katabatic. It is called katabatic wind. And then as slope A or B will be warmer slope. Slope A or B will be warmer slope. Slope A or B will be warmer slope. So what is happening is that we are saying where is which one is warmer slope there? Slope A or B will be warmer slope. Which one will be warmer slope? So as you can see there, you can see that as you see A, we have got frost sensitive and so forth. It means this is a code. This is a code, or it's a code slope. So B is warmer. B is the one that is warmer. As you can see there, we are saying B is the warmer slope, which we are given there. B is the warmer slope. B will be the warmer slope. As you can see there, we are saying uh, we are having the warm air there that is there, and then we are saying the temperature inversion layer, it actually prevents the rising of the wind. We are saying a decrease or an increase of temperature with the height. That's the inversion layer. That's what the inversion layer do. So peaches, oranges will be planted on the valley floor. Which type of crops will be planted on the valley floor? Here we want a type of a crop, a type of a fruit, a citrus plantation that is frost resistant. Which one is it? So between peaches and oranges, a frosty resistant type of citrus plant or crop is what it is. Oranges will be planted on the valley floor. Oranges, they can resist frost. They are frost resistant than peaches. You understand? So question 1.4, uh, the invasion uh, the invasion developed due to the displacement of dash invasion layer. Invasion layer, it occurs because of displacement of warm air. Warm air is displaced. Invasion layer is formed or is developed due to displacement. We are saying removement, or I mean removal. It is removal of warm air that causes the invasion layer to develop there. So we are saying we have got an invasion layer that is forming in the valley there, which is at certain temperature. We're saying a warm air that is found uh, enclosing the river there. On the river floor, we have got cold air, but as we go up the floor, up the slopes of the river, we are saying it is submerged with warm air. We have got a photograph that is based on urban climate. So we said in the beginning that uh, microclimates can be formed or can be typically be explained by valley or urban. So urban climate is a typical example of also microclimate. So how do we say that it's an urban area? We are saying we can identify that by the type of buildings that we are seeing here. These are vertically expanded buildings. We are talking about the congestion of buildings there. These are able to explain that this is an urban city or urban climate, and therefore We have got also corridors that are formed. We have got passages that are formed here. We have got passages that are formed between flats or between buildings, which will say that they are there to channelize the wind or the air. And then we also have a lot of concrete surfaces that you can see there. It is congested of buildings that are concrete done. And then obviously, let's look at the next the question that are following. The study of climate is in a city is known as what? I said that this is called as micro, it is known as micro. We are talking about the study of climate at a small scale. At a small scale, at a small scale, we call that micro. It is microclimate. It is called microclimate. Macro is when we are talking at the something or the we are studying and analyzing something at a large scale, at a global level. Therefore, we say that macro climate. We can talk about the South African climate. We can talk about the Southern African climate. We can talk about various regions that we can define as macro. So micro is at a small scale. A dash doom, a pollution doom, a heat island occurs when there is an accumulation of soot. We are talking about smoke, soot. We are talking about smoke, carbon gases here. The accumulation of soot, dusty, and smoke over the city. So, what is this that can form? What is it that can form when we have got dusty, we have got smoke, and we have got soot? We are saying all these results in a pollution doom. They result in a pollution doom. A pollution doom, it is a phenomenon that develops because of accumulation of or intense accumulation of carbon gases in the atmosphere, which we find also in urban areas. So therefore, what we are saying is that this is a what? A pollution doom that is caused because of these carbon gases that we are talking about. A heat island, we are talking about an extensive increase in temperature within the cities, other than, I mean, higher than their surrounding areas, which are rural areas. So temperature tend to decrease from the city to the rural areas when we are looking at an urban heat island. So this is a pollution doom that is formed as a result of accumulation of pollution substances or elements that we are finding there. And then dash, whereas artificial surfaces, urban activities is the factor that contributes to higher temperatures over the city in the photograph. What is the factor that contributes to higher temperatures over the city in terms of this? So we cannot talk about urban activities. We can't really talk about urban activities increasing. But what happens is that we need to talk about artificial substances. Artificial substances, we have got a lot of buildings that you can see here. Some of them, they are air conditioned. We talk about the building materials that are used. All these, we are saying they are artificial substances or artificial materials that are resulting in the formation of urban heat island. So urban heat island, it is caused because of the development or the accumulation or the use of artificial 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 surfaces artificial surfaces artificial surfaces. They result in the formation artificial surfaces. They result in the contribution of higher temperatures over the city according to the photograph that we are given there. And then we are given the infographic on mid-latitude cyclones, where we have got a cross-section that is given direction of movement, which is west to east. And then we have got our weather map, that is a synoptic weather map that is given here. It's a synoptic weather map that is given here. And then we want to understand like thousands of homes in informal settlements damaged in Cape Town storms. So we are having torrential rains and flooding have damaged thousands of informal structures in and around Cape Town. Disaster risk management said on Friday the city's the metropole was struck by heavy rains, gale force winds, high seas, the plummeting dropping temperatures this week. On Wednesday, the city saw flooding, informal settlements and roads with rain and thunder, and heavy snowfall recorded in northern Cape, Overberg regions of western Cape. Uh, we are saying the disaster risk management spokesperson said the rains caused substantial flooding in informal settlements across the city. So our first question is saying, according to the infographic, uh, according to the infographic, in which direction does the mid latitude give? We are already given there. It is that it is given. It is moving from our mid latitude cyclone. It is given that it is moving from west to the east. Infographic mid-latitude cyclone direction of the storm, which is shown here. Direction of the storm, it is west to the east. It is given that it is moving from west to east, west to east, which we can say easterly direction, because it is moving from west to the east. So it is shown that the direction of movement which we are having here is west to the east. And then the next question is saying, why do cumulonimbus clouds develop ahead of the cold front? Why do cumulonimbus develop ahead of the cold front? Cold front one, warm air rises sharply along the steep cold front. The sharp rising, the sharp ascension of warm air and intense upliftment of the air along the cold front results in what? There is massive upliftment of the air here. There is massive upliftment of warm air. The massive upliftment, the massive upliftment of warm air results in the formation of cumulonimbus clouds because of the steep cold front that is there. So that intense upliftment results in formation of what? Results in formation of cumulonimbus clouds. And then why does the type of rainfall at B differ from the rainfall at A? Refer to the weather map. So if we look in the diagram there, why is the type of rainfall in A, B different from type of rainfall from what? From B. We are saying in A, we have got we have got heavy showers. Here we have got moderate light showers. And then, as you can see, reasons for that, we are seeing this is a what? This is the cumulonimbus clouds, which is actually associated with heavy rainfall. The type of the cloud, also stratus clouds, it is also associated with moderate light rainfall. Moderate light rainfall is associated with what? With the type of the clouds that we are given there. So what we need to understand here is that, as you can see, there is a gentle gradient at B that results in the formation of stratus clouds and hence light rainfall. And then as you can look there, I'm saying the gentle gradient at B, which is we are saying the stratus clouds that I've already shown you here, that we have got at B, we have got a gentle slope that results in the formation of the stratus clouds that we are seeing there. Therefore, the stratus clouds, they would always result in what? In lighter rainfall. So we have got lighter rainfall because of this type of cloud that we are talking about. And then B, like I said again, in A, there is cumulonimbus clouds that result in heavy rainfall, and stratus clouds cause soft rainfall penetrating or light rainfall. So what we are saying is that the type of the clouds that are found on A and B. So on B, this is A. There is what? Cumulonimbus clouds that are associated with heavy rainfall. that is actually different from B, which has got light rainfall. In any case here, we are also talking about the ability of infiltration of the rains. So therefore, in A, we have got a massive runoff. There is chances of higher runoff than in B, where the waters is able to penetrate and infiltrate as it is light and moderate there. So give evidence that a warm front occlusion developed. Warm front occlusion developed. What happens there is you can actually see the symbols. Symbols are used to show the type of cloud. So we are saying we have got the warm front symbol at the apex or at the top, the home front occlusion. What we are saying is that we have got a home front occlusion that is given, which represents that we also have what home front occlusion that is taking place. Home front occlusion that is taking place results in that type of we are saying the home front symbol at the apex, which actually represents that there is a home front. So what we are saying is questions such as these. I told you before that when we talk about types of occlusion, we are saying we remember we said this and that it remains. We have got symbols that are used where we say that uh, triangles are used to represent, and also semicircles can also be used to represent types of fronts. So now, what I'm saying is that when we have got a type of, say, warm front occlusion, it means we have got the warm front occlusion that is forming or that is shown on the diagram. And then how did the warm front occlusion develop? Chord A is found ahead of the warm front. Remember, we said that an occlusion or a type of front is caused because of the type of air that is moving. If you can refer to previous presentations, I'm sure you can be able to understand and relate these conditions very well. And then cold air is undercut along with the warm air. It is undercut, so therefore we are saying the coldest air is found ahead of the warm air. So the warm air is behind the cold air. So it undercuts that cold air. Therefore, it results in what? In warm front occlusion, because it is the warm air, or it is the warm air that is moving, undercutting the cold air. So therefore, what happens is that a warm front occlusion develops in that regard. State one element of weather that is associated with cold front according to the structure. Obviously, we are saying that besides going back to the diagram, we are saying weather elements that are associated with cold front. We have got rainfall, we have got also the issue of temperatures and also winds that are there to say that when we talk about cold fronts, there is always rainfall and temperatures and winds associated with them. Number 7, explain how the weather conditions associated with a mid-latitude cyclone would negatively impact the residents in the former settlement. These are actually given there to say that obviously because of the heavy rains that are there, they would result in flooding. It is also given in the case that flooding of homes, there is cases of flooding that would result, and then also the destruction of infrastructure destruction that can also happen there. Will cause also informal settlement to have rains will cause informal settlement to become inaccessible. They cause informal settlements. We are saying people cannot be able to enter. People cannot be able to get into these informal settlements. Remember again, there is no roads there. The roads, maybe they are there, but they are gravel roads. So they are washed away by the rains, and therefore we would have problems in accessing the informal settlements. Low temperatures would cause residents to fall ill. We have got cold flus that can result. We can talk about sinuses that also form there, and then fever which can also come as a result of problems to do with the cold weather and rain that is experienced within the place. Gale winds, the gale force winds destroy and damage informal structures. Remember, we talk about strong winds. These are strong These are strong winds, very strong winds, which can also blow or take off the informal structures that we are looking at and that we are talking about. So therefore, it can be also a problem that can result in cases of what mid-latitude cyclones that are happening within this area. We are given the tropical cyclone, we are given the tropical cyclone, which is referred to the sketch below showing the path of a tropical cyclone, Freddy. Freddy is the name of the tropical cyclone. So refer to it, and then we are given this tropical cyclone there. So now, as you can see, X is representing the eye. It is representing the eye of this tropical cyclone. And then we are also given that the direction of movement, which is shown. We say that where it looks like feather-like, it is wide open here, it is wide open, and then it becomes smaller, showing the direction is that it is keeping on moving, going this direction. So it is going to the east, as you can see. So now, how many tropical cyclones developed before Fred? We said that tropical cyclones class, they are named according to the people who discovered them. The first name of the person, or the first name of the first letter of the name of the cyclone identify the types, the number of cyclones. So here we are saying before. We are saying before. So when we look on alphabet, A, B, C, D, E, F. So before F, so we are saying we have got A, B, C, D, E types of cyclones that occurred before F. So these A, B, C, D, E occurred before F. So what we need to know is that we have got one, we have got two, we have got three, we have got four, we have got five. So 1, 2, 3, 4, 5 are representing other types or other cyclones which occurred before Freddy. So Freddy is the what? Is the sixth. We are using the letters, the occurrence and the appearance of the letters of alphabet that defines how many tropical cyclones have occurred. So before we are having 5, as I have illustrated to you that we use the letters. So please take note, there are questions which gonna come whereby they say before, or they say including, or saying the next cyclone that can come after Freddy, what can it be? If we can say that there is another next cyclone that can arise. So you need to understand that the letters of the alphabet defines the number of cyclones that have hit a given place. So here we are saying that there are 5. In which country did Freddy first make landfall? In which country did it first make landfall? As we are seeing there, we are given that it is first Madagascar that you can see here. It is first Madagascar that you can see there. So now, what we want to understand is that Madagascar is the first country which it actually makes a landfall. I hope that we are together and people are understanding all these things that we are talking about. People are understanding and following properly, so, and then give a reason for your answer. I have already given that there is that identification that I have demonstrated. So I just erase now that it moves in the easterly direction. It is moving in the easterly direction, which is given there on the what? On the on the photograph. And then we also have to say that it moves from west to east. Obviously, that is easterly direction. First country in the east to the path of it is the first country in the east to west part of Fred. Are we together there? So we are saying according to the movement that is happening, and don't forget that we are also given that from the information, I mean, from this, we also need to understand that these tropical cyclones, what is happening is that it is moving from Mozambique, and then where does it go first? It is going to go to what? The next country that can be there, or the first country from where it is coming from. It is what? It is Madagascar, as according to the direction of movement. And then why did Fred intensify between 22nd and 23rd? Why did Fred intensify between 22nd and 23rd? 22nd and 23rd. Why did it become so strong between 22nd and 23rd? As you can see, it is 16. It is 16. Of course, we are saying, why did it intensify? If you can look there, what is happening is that one, it reached warm water after landfall. High temperatures and evaporation energized the system. Here, what you need to understand is that there are conditions that are necessary, conditions necessary for development of tropical cyclones are present. So in any case, the examiner is here trying to test us that do we know what is happening, what causes an increase, what energizes, what propels the development of tropical cyclones. So we are talking about higher temperatures and evaporation that also stimulate, or that facilitate, or that energizes the system. No more friction over the warm waters, and then increase in latent heat. The latent heat is also continuously produced or released. Remember that we are saying that the latent heat of vaporization, which is also released here, it is also necessary for the development of tropical cyclones. So in this case, that is why you see, that's what we are saying in that regard. So refer to X on the satellite image, and then name X as indicated on the satellite image. I've already mentioned that if we look at X, I said that it identifies the eye. It identifies the eye of the tropical cyclone. It is identifying the eye of the tropical cyclone. It is identifying the eye of the tropical cyclone X. It identifies the eye of the tropical cyclone. And then mention one weather condition at X. We say we have got clear skies. The skies are clear there. What happens is that the clear skies are there at the eye of a tropical cyclone. Remember that there is high temperatures also, which are caused because of the subsidence of the air falling there. No or very little wind, and then no precipitation, because we say that the air is what is falling. So as the air falling, it warms up. It warms up, and also no precipitation, no rainfall, and also very calm or little wind, or little wind can be found in this zone. That is what we are talking about. That is what is happening with the eye of the tropical cyclone. These are factors or conditions that are found. Conditions, we are saying weather conditions. These are weather conditions at the eye of a tropical cyclone. The weather conditions at the eye of a tropical cyclone, we know that there is no rainfall. These are the conditions that are there. Like I said, these arrows are showing uh, uh, falling winds that gonna warm up as they fall. I'm sure this you can look again in our previous presentations. You can understand this. Describe the reason for the weather conditions that are there. We said one, these are obviously what I have already been describing now. Descending air causes clear skies that are there. The air as it descends, we said that is falling air. It causes clear skies. Heating up of descending air causes high temperatures. As air descends, it results in high temperatures. Also, weak pressure gradient leads to no or very little wind. That can also be there. Again, we have got also loss of moisture due to descending air causes no rainfall. When the air is descending, we are saying this results in weather, dry weather conditions, dry weather, dry weather conditions results in this case. Dry weather conditions, the results in this case. So now, what we need to understand again is that how would the weather conditions at X negatively impact the coastal biodiversity of Mozambique? How do they affect the uh, biodiversity of Mozambique? So now we need to know that this we have got St. John's will be blown away. We have got erosion of the coastline will increase. We have got fauna and flora at the base will be destroyed. We are talking about plants and animals. Plants and animals will be destroyed. Habitats and food chains will be disturbed. Also, we talk about the salinity of the marine ecosystem will be lowered. We talk about the cleanliness, the destruction of the infrastructure will pollute the water. These are conditions that are caused because of how will the weather condition negative impact on the cost of biodiversity. So now these are the weather conditions that would also result there. And then refer to the factors that influence the weather over South Africa in winter. So we are saying this is the weather factors or weather factors that can affect South African weather in winter. So we have got the Kalahari high pressure. We have got our three anticyclonic, which is Indian, and also thirdly, we have got the South Atlantic high pressure cell. So we are saying these are factors that affect the South African weather in winter. So we are given that the Kalahari cell dominates strong subsidence. We have got the escarpment that is given here, or also the plateau, and then we have got the formation of the what of the invasion layer. Warm moist air rises, but therefore it is covered by the what by the invasion layer that we are seeing there. So these are the various conditions that we can identify in the interior of South Africa in winter. So identify the factors that are two factors in the sketch that influence the weather of South Africa. We are saying we have got this was anticyclones. We have got the Kalahari high anticyclonic, the South Indian, the South Indian. We have got the South Atlantic, the South Atlantic, also high anticyclonic conditions, and then the ocean currents also can result in the formation of the weather or result in weather condition that we are seeing. We are also seeing the presence of the plateau or the escarpment also, which is resulting in the invasion layer that we are seeing here, the Kalahari high pressure cell dominating the there that is shown, resulting in strong subsidence, the strong falling of wind that is given here. Therefore, what happens here is that we have got weather conditions in South Africa as a result of these three factors. And then how would the position of the South Atlantic influence the weather of the west coast of South Africa in winter? South Atlantic, how does it influence the weather on the west coast? If you can look on South Atlantic, you can see that how does the Benguela currents here that we are seeing, how does this affect the weather on the west coast? On the west coast, we are looking on the western side of what of uh of South Africa. So now, what we need to look at and understand is that the west coast of South Africa, how is it being influenced by the South Atlantic high pressure? Anticyclonic movements will feed the country with cooler air. One, cooler air will be fed there. It would allow mid-latitude cyclones to pass over the Cape Town again. That is two. And then there will be heavy rain, low temperatures, heavy rain, low temperatures, strong winds, and low humidity in Cape Town. All these are various factors that we can find, that we can see as a result of the anticyclonic uh, what is it? The South Atlantic high pressure cell, which is on the west coast of South Africa. So basically, it actually affects Cape Town by having heavy rains there, the low temperatures, the strong winds, and low humidity that are there, which are also because of the anticyclonic movement, which will feed the cooler air from the west side of the country there. And then, why is Kalahari high pressure dominant over the land in winter? The dominance of Kalahari high pressure. This question class is one of those typical questions which you should always look forward. So we are saying that the Kalahari high pressure, as you can see also from the photograph there, it is given that there is strong subsidence that you are seeing on the photograph there. Why does it dominate? The dominance, it is one, it is part of the subtropical anticyclonic system that changes position with the revolution of the Earth. The revolution of the Earth actually causes the subtropical anticyclonic system that also we are talking about in terms of the changing of the position. And then weaker convection currents on the surface to force the descending air from Kalahari upwards. So as you see, the wind is descending from the escarpment there, that plateau, the plateau subsidence. I'm saying what happens is that also we have got, I mean, what happens there when the air falls and then it descends into the interior there, what happens is that there is weaker convection currents that are coming from the sea that can which can also force the descending air from Kalahari upwards. So the air has got all the powers to go down because there is no weaker. We are saying weaker convection currents. Weaker convection currency can also cause this condition that we are talking about. Weaker convection currents on the surface to force the descending air from Kalahari upwards, as you have seen from the arrows that I demonstrated, I showed you there. How does the dominant Kalahari high pressure cell influence the presence of the invasion layer in B? You see, this one, class, look forward. This is one of the questions that is always quite dominant. The stronger descending air hits up adiabatically. We are saying it hits up as it goes down. As it goes down, it increases the temperature by 1 degree at every 1 degree per every 100 meters fall. So as it falls from the escarpment, temperature increases by 1 degree Celsius up per every 100 meters fall. So causing high temperatures and higher, causing higher temperatures higher up in the atmosphere, as you can see. So we are saying the dominance of Kalahari high pressure cell influence the presence of invasion because the stronger descending air hits up adiabatically. We are saying as adiabatic, we are talking about the change in air temperature with the height, the change of air temperature with height. So therefore, in this case, when the air is descending, it hits up. So the air is heating up. So therefore, change of air temperature with the height is what we are looking at. Change of air temperature with the height. So temperature of the air, it increases as it falls down, which causes it to increase. So therefore, it actually influences the presence of the convection layer in sketch B, that you can see that there is a what you call the inversion layer there, which you are seeing there. It is caused by the descendants of the air, the subsidence of the air, which causes the air to what? It causes uh, the air to warm up, which we are saying this is by 1 degree Celsius per every 100 meters 4. Per every 100 meters 4, the temperature warms up by 1 degree. That is what is happening there. That is what is happening. So we want to look at the last question according to today's presentation. We said we are looking at what? Climatology. So in a paragraph, approximately 8 lines, explain how the position of the inversion layer will bring clear and stable weather conditions over the interior of the country in winter. The presence of the inversion layer. Basically, I always say that the 8 lines must be focused to give points, don't just write. So one, what you need to understand is that there is strong subsidence of air down the plateau that we have already talked about. The air heats up adiabatically, which we talked about again, that the air heats up as it falls down. An inversion layer forms below the plateau. The inversion layer forms below the plateau, which also is another point that we can also talk about. We are saying that is also another point that we can also identify that moist air from the warm Mozambican currents reaches up the South Atlantic, the South Indian high pressure plateau. It actually we are saying it actually hits the warmest air from Mozambican currents. It reaches from the South Indian high plateau, and then the moist air cannot reach the interior. Remember that when the air rises, it cannot reach the interior of the country because of the position of the inversion layer. Therefore, there is little cloud formation and hence little rainfall that can form in what? In winter. The inversion layer, it encloses the air from reaching into the interior of the country. The air that is rising from the warmest air that is rising, it cannot get into the interior because the inversion layer, it blankets the warmest air that is rising, as you can see from the what? From the diagram there. So please, class, just note that the whole concept is about the heating up of the subsidence. I mean, the heating up of the air as it falls down, and then the formation of the inversion layer below the plateau, which also causes a ridging, which is caused because of the South Indian high pressure. And then we have got the warmest air failing to reach into the interior of the country because of the position of the inversion layer, resulting in little or no rainfall in winter. So basically, that is it. Thank you very much for watching, and thank you for following. All the best, and keep on connected. You never go wrong. Let's meet again in the next presentation. We are going to talk about geomorphology as you prepare for your exams end of the year. To keep on connected as you prepare for preparatory. This is the channel. This is home. I told you that you never repeat. This is home. This is family. Together we do this, and keep connected. Don't forget to subscribe, share, like, and also turn on your notification buttons to keep posted. Have a wonderful stay.